Students, if you missed today's Zoom meeting, this is for you. I'm just going to go over the problems that we talked about along with a few more things. This is available for you to print out on Canvas if you want to, or you can just follow along on a sheet of scratch paper. So you should have access to your STAR formula chart that has all the formulas on there. It was also on the notes. Again, if you can't print it, make sure you write those formulas down and have them handy when you take your quiz this week. So for this first one, it's area of a rectangle, which if you look at the formula sheet, the way we do this is base times height. It's really the same thing as length times width. It's just another way to look at it. So for this particular rectangle, if the top is 18.3, the base would be 18.3 as well. So we're going to multiply 18.3 times 5.9. Go ahead and do that. Okay, hopefully you got to work that out on your own. For the sake of time, I went ahead and paused it while I was working it out. Remember, you need to add this placeholder 0 when you're moving over to multiply with a 5. Once you add up, because this problem did have decimals in it, there were 2 digits behind the decimal points in the multiplication problems. We've got to make sure we do the same in our answer. And this is our answer right here, and we always want to put the label with area. We use square units, so we can write it with a little squared symbol with a little 2, or we can write out the word. Okay, before looking at number 2, we did have some confusion today in the meeting, so I'm going to go down. Now, this is not on your page if you printed it, but you can certainly write it down. We need to know the difference between area, perimeter, and volume when we're reading a word problem. So, area is when you need to cover something. It might be paint, carpet, material. Area covers the surface of an object. Perimeter is like the rim. It goes around the outside. It's like a border, a frame. Fences deal with perimeter. And then volume is three-dimensional. It fills a container. It is how much a container can hold, how much space it takes up. So when you are reading problems, I don't want you to get confused with those different things. On this problem number 2, we should be solving for area, but I did have some students solving for perimeter in the Zoom today, so I just wanted to discuss that really quick. So back to problem 2. So here's a keyword. She wants to cover the entire area of a bulletin board. That should key us in that we need to find the area. We are completely covering the surface. We're not just going around the outside edge. Now, if she was talking about the little border that teachers put up on the bulletin board, that would be perimeter, but she's talking about the covering. So she's covering it with construction paper, and this is a really small bulletin board. It is a square, and it has 21-inch sides. Another thing we need to note is squares, all of the sides are equal, so every single side would be 21 inches. And we want to know how many square inches of construction paper will Miss Donnelly need. Okay, another thing I should have added to my table, that just made me think. When we're talking about area, it is always going to be in square units. Oh my goodness, I can't type. So just knowing that could clue you in on a question. Perimeter is a straight unit, so it's just going to be the units, inches, centimeters, whatever. This would be square inches, square centimeters. And then volume is cubed units, or units cubed. So that's another way you can decipher what type of problem you're going to be doing. Okay, so back to this problem. We want area. It's a square. We know area is base times height. And if we think about a square, all of the sides are the same. So whatever the base is, the height is going to be the same. And we've been told that it's 21 inches. So all we have to do is multiply 21 times 21. Go ahead and pause and make sure you can do that multiplication. Don't use a calculator right now. Let's not get rusty. This is just for practice. Okay, that math was a little bit easier because there were no decimals involved. If you worked it out, hopefully you got the same as me, 441. And this is just another way we could write it. Instead of inches squared with a little 2 like we did here, we can write 441 square inches. So that is how much construction paper she needs to cover that bulletin board. Okay, on to a parallelogram. If you watched the lesson videos, you should know that a rectangle is really just a special parallelogram. So we use the exact same formula to find area. Area is base times height. This one's really nice. They have the base and the height clearly labeled. Sometimes they will throw in a measurement for this slant height. That is to throw you off, so don't get confused with that. If we're measuring height, we're talking about if this parallelogram were sitting on a table, we'd want to measure from top to bottom. We wouldn't measure all the slants. So think about that. Don't let those trick you if they do show up on your quiz. So we're using just the numbers given, 5.6 times 4.7. Go ahead and pause here and see if you can do this math, and then press play when you're ready to check your work. Okay, hopefully you worked it out correctly and you got the same answer as me. If we multiply and then add it up, my line kind of disappeared here. After adding, I got 2632, and then because I have 2 digits behind the decimal points in the original problem, I have to have 2 digits behind the decimal point in my answer. So 26.32 meters squared, or 26 and 32 hundredths of a meter squared is our answer for that one. Okay, now we are moving on to volume. The volume equation is a little bit tricky. The reason that we're writing it this way, though, is so that when you get older and you're working with any type of prism, you can use the same equation. So it does have a purpose. It is kind of weird when we are first learning this equation. So its volume equals capital B times H. Now be careful, that capital B is different than the little b we have in the area equation. The capital B is base area, so we've got to find the area of the base of the prism first and then multiply by the height of the prism. This prism has a rectangular base, so our formula is the area of a rectangle, base times height. This little b is talking about the base of just the rectangle. So if we looked at just this rectangle that I highlighted in yellow, we have 10 and 2. 2 could be the base, 10 could be the height, or 10 is the base, 2 is the height. It doesn't matter. But that area, 2 times 10, is going to be 20. So in this situation, big B is 20, and then the height of the prism is 8. So we need to do that math. 2 times 8 is 16. Add the 1 0 that you have in the problem. You get 160 centimeters cubed. Because it's volume, it's going to be a cubic unit. Now, if I turned this prism over on its side and I said that this part of it was now the base, I would get the same area. My base is now 8 times 10, so 80 would be my big B. 80 times 2 gives me 160 as well. So with a rectangular prism, we could really turn it any way we want for the base, and we would get the same answer. As you get older, you're going to have triangular prisms, hexagonal prisms, trapezoidal prisms, and prisms are named for their base shape. So just remember that. With a rectangular prism, it could be any of the faces on that shape, but it will get more specific as you get older. Okay, question 5, we have another prism, but this one we're working backwards. We know the volume. We're given the volume. They tell us the candle is going to have a volume of 99 cubic inches, but they want the width, which is this measurement down here. So if we think about our volume equation, remember volume is big B times H. So the base area, which we can't really see the base in this case, but it would be a little rectangle down here, times the height. We know the height of this candle mold is 11 inches. We don't know the area of the base yet, but we're also told the volume is going to be 99. So we know we can always solve an algebraic equation if we're missing just one piece. Right now we have big B times 11 equals 99. A lot of you could do that in your head, but we can divide by 11 to see what big B should be. Now we have that b by itself. 99 divided by 11 is 9. So if 9 is big B, our base is a rectangle. So to find the area of a rectangle, we do base times height. So we would do 3 times W to get the area of that rectangle, which we just figured out is going to be 9. So we actually have a square base because if we divide by 3, our width, 9 divided by 3 is 3, so this piece is 3 as well. So the answer here would be 3 inches. Now I wanted to talk about one more problem that was on the Khan Academy practice. It was a parallelogram. It looked kind of like this, and as we know, to find the area of a parallelogram, it's going to be the base times the height. When we're talking base, we have to imagine that the parallelogram is sitting on a table. So this parallelogram, if this were my table, it's not really sitting on it right now. I could, and now you can't do this on a computer screen, you kind of have to imagine in your mind or draw a picture, but I can rotate my parallelogram because I made it that way. So if I wanted this one to sit on the table, I'd have to turn it a little bit. But to find my area, I need the height. Well, the way that they've marked this, I don't have the height if the parallelogram is going to sit this way. This 4 is talking about this slanty part. Height has to be straight down. So, and again, this is on the Khan Academy practice. For this particular one, you have to imagine or redraw this parallelogram. We could rotate it and sit it on the table. Now we know what the height would be. It would be 5, and the base would be 4. So the area of this parallelogram is 20, and I think it's 20 on that Khan Academy, but just remember, sometimes you're going to have to rotate and manipulate shapes. Draw yourself a picture. If you have some sort of tracing or see-through paper at home, a good strategy, and I would have shown you this if I had you in my classroom, but you can lay the paper over, trace the shape, and then rotate it so that you can see what the height should be and things like that. So just remember, sometimes you have to turn the shape. If you're a visual learner, you can do it in your head. Some of you might need to redraw it. Email me if you have any questions. You guys keep up the good work and have a great week.